Okay, Unit 4, classifying triangles. We're going to classify triangles by their angles and their sides. So, classifying triangles by angle. And we've been talking about this already plenty, and you already all know this. Acute angle, an acute triangle, all the angles are less than 90 degrees. So we've been talking about acute angles plenty. Now we're applying it to triangles. A right triangle has one right angle. Because if you think about it, there's no way to have two right angles in a triangle. It's not possible. There's no way to close and make it into a triangle if we have two 90-degree angles. Because think about it, 90 and 90 is 180, and a triangle only has 180 degrees. So where's the third angle going to fit in? It doesn't. And obtuse, kind of the same idea. You can only have one obtuse angle. Because if you have an obtuse angle here, and an obtuse angle here, there's no way to make a triangle out of that shape. So you can only have one obtuse, one right. And acute, they're all acute. Now, we also have equiangular, meaning equal angles. And that's when all of them are 60. It's actually called, we'll be referring to this later, a 60-60-60 triangle. So if you notice here, these pictures, obviously this is going to be a right triangle because we have the symbol right here. 35 and 18. Well, we got to figure out what this angle is. 35 and 18 is 53. 180 minus 53 is 127. So since this is 127 degrees, that makes this an obtuse triangle. Here, 68 and 55. That's 123. 180 minus 123 is 57. Which makes this acute because all of them are less than 90. Now we can also identify them by their sides. Scalene is when no sides are congruent. Isosceles is two sides, and equilateral, meaning equal, lateral means sides, means all three are congruent. And once again, we'll use our markings, our hash marks, to do that. So, classify as acute, equiangular, obtuse, or right. Well, right here, as soon as we have one over 90, that's obtuse. Exactly 90 is right. All three under 90, acute. And a 60-60-60, equiangular. Also acute. It's just a specific type of acute triangle. Now, ABE, right, equilateral, isosceles, or scalene. Okay, well, ABE, let's see what that is. ABE. Well, we know that this is 8, and every hash mark with 1 is also 8. So we can go through and mark all of these 8. Well, ABE has a side that measures 8, a side that measures 9, and 8 radical 2. They're all different, which makes it scalene. EDB. EDB. Well, it has 1 8, another 8, and 8 radical 2. Since two of them are the same, that makes it isosceles. EBC. E to B, to C. Well, this is 8. This is 16, and 8 radical 2. Well, again, none of the sides match up, so that's scalene. DBC. DBC. 8, 8, 8. Equilateral. Equal sides. And notice we had 2 scalenes, an isosceles, and equilateral. Now, ABE, I want to go back. Well, never mind. That's it. I don't want to do anything else right now. Classify each triangle in the figure by at the right or below by its angles and sides. Oh, so this is both now. ABD. ABD. Well, notice there's a hash mark here, a hash mark here, and a hash mark there. That makes it equilateral. All equal sides. And it's also acute. All the angles are less than 90. ABC. ABC. That's this big one right here. Well, this has 1 hash mark. This has 2 of the same hash mark. So let's pretend this was 5. That would make this 10. So either way, AC is double AB. And then this side is not marked, except up here. So we'll call that scalene. And notice we do have a right angle mark up here, so it's scalene right or right scalene. EDC. EDC. Well, notice we have 1 mark here, 2 mark here, nothing here. But since it's right, we can see it's right. We know it's a right triangle. And since it's right, that makes this the hypotenuse, which makes it the longest side, which means it has to be in different measurements. So it's also right scalene. And last but not least, BDC. BDC. Well, we have 1 here and 1 here, which makes it isosceles. And notice, if this is 90 and this opens up wider than that, that makes it obtuse. Now, example 4. Find x and the length of each side if ABC is isosceles with AB equaling BC. Now, I know it doesn't look like it, but they're saying that AB, right here, is equal to BC right here. So we just do what we've been doing for a while and set these equal to each other. I'm going to subtract 2x. Now I'm going to add 3. Divide by 2, x is 4. But it says not only find x, find the length of each side. So I plug 4 in here, 4 plus 2 is 6. Over here, 2 times 4 is 8, plus 5 is 13. Which is the same over here, 4 times 4 is 16, minus 3 is 13. So that works out. Find x in the measure of each side. FGH is an equilateral triangle. FGH. FG is x plus 5. GH is 3x minus 9. And FH is 2x minus 2. Well, if it's equilateral, that means all three sides are the same. You can put either any of these two to equal each other. So x plus 5 equals 2x minus 2. I'll do that one. I'm going to subtract x from the left and right to get x minus 2 equals 5. I'm going to add 2 to both sides and get x equals 7. Well, let's check it out. If I plug in 7 here, I get 7 plus 5, which is 12. If I plug in 7 here, I get 2 times 7 is 14, minus 2, which is 12. Now if I put 7 here, 7 times 3 is 21, minus 9 is 12. Now I could have done this with 3x minus 9 equals x plus 5, or 3x minus 9 equals 2x plus 2, because if they're equilateral, all three are the same. Example 6. This, if you remember, is the distance formula. So what we're going to do is we're going to we could put this on the grid, we don't have to. So negative 3, negative 2, very hard to read, but this is negative 3, positive 2 is right here, that's x. And 2, comma 1 is y. And negative 2, negative 3 is z. Now we don't really have to draw. All we have to do is do the distance formula from x to y, from y to z, and from x to z. So we just have to do this formula 3 times. It's a very simple formula. Distance equals the square root of x minus x. So I'm going to do xy first. Negative 3 minus 2. Those are my x's. Squared. Plus 2 minus 1. Squared. Negative 3 minus 2 is negative 5 squared. Plus 2 minus 1 squared. So that's 25 plus 1. So that's the square root of 26. We don't need to get the decimal, that's fine. Now I'm going to do y to z. So distance equals the square root of 2 minus negative 2 squared plus 1 minus negative 3 squared. Well, this becomes plus, so that's 4 squared. This becomes plus 4 squared. So that's the square root of 16 plus 16, which is 32. And now I'm going to do xz. So negative 3 minus negative 2 squared plus 2 minus negative 3 squared. Well, that gives me, remember this becomes plus, negative 3 plus 2 is negative 1 squared, plus 5 squared. So that becomes 1 plus 25, which is 26. So I have the square root of 26, square root of 26, and the square root of 32. So remember, this was xy, this was yz, and this was xz. So that means xy and xz are the same measurement. Which means this is an isosceles triangle. And there you go, that's it.